Hey there, and welcome to another one of my cheesy YouTube videos. On this video, we are going to repack the tilt cylinder on my neighbor's tractor. So let's get started. This old tractor is a John Deere 7405. It's got a John Deere 740 lift on it. The left-hand tilt cylinder is leaking, and we're going to repack it. The first thing you want to do is make sure there's no load on the cylinder. So before the owner got off the tractor, I had him shut it down and work the hydraulics to deplete all the pressure out of the cylinders. I did that for both the lift and the tilt. That way, if we relieve the tension on the tilt, he doesn't relieve it on the lift could drip down and put pressure on the tilt. So the cylinder is loose. Usually on these John Deere cylinders, there's a number stamped in it, and that would be the part number, and it's real handy in finding the seals. My neighbor's already got the seal kit, so it's not that critical that I find that number, but as we play with it, we'll look for a number. First thing we're going to do is we're going to take the gland out of the barrel. Keep in mind that as however many engineers there are ways that hydraulic cylinders are assembled. So I would recommend to you that you inspect all around the barrel on the gland end and just look for any chance that there's a set screw in there. This one shouldn't because of the way it's assembled, but if the gland were to thread into the barrel, there's a possibility there could be a set screw. And some barrels have external threads, and a lot of those will have set screws. What we have here is a big snap ring on the outside, and I need to take a snap ring pliers and pull this external snap ring off. Then this is the gland right here. Once the snap ring's off, then I can drive the gland back into the barrel, because then inside the barrel towards the end here should be an internal snap ring, and once the gland clears that snap ring, then I can take probably a screwdriver or a pick in there and pop that snap ring out. Then we'll take the pin out and we'll snatch on this rod, and it should snatch the gland out of the barrel. There's going to be an O-ring inside there, and that may hang up and take a little effort, but we'll cross that bridge when we get to it. Snap rings off. Be careful not to nick the cylinder when you're driving the gland back through there. Get the back hydraulic line of the cylinder off. And I'm being careful with my blunt chisel. And I'm driving the gland into the barrel. Keep my chisel off that rod. Being patient. Try not to damage the gland. Take some brake cleaning. Clean this up. It's got to go back about 1/4 inch. There it goes. All right, inner snap rings out. Just wasn't holding my tongue right. I pull a little pin out, push a big pin out, then hopefully pull the rod out. The rod and the barrel have got this kind of a bind on it. And that's put a block under that barrel somehow and just kind of keep the barrel up a little bit. I'm using a lot bigger hammer. I got a crescent wrench through the pinhole of the rod end, and I'm hitting against it. Piston's coming out. Bastard. Piston seal is probably hanging up. I went ahead and pinned the rod in back up to where it was pinned, and that actually folded back and made a perfect setup. So I can work on getting the nut off, pull the piston off, pull the gland off, put new pack-ins in, put it all back together. Inch and 5/16 wrench takes the nut off. I am thinking this rod has got a slight bend to it. I'd have to say that's probably because he's been pushing brush and stuff, so maybe that was the reason. There's the piston. Here's the gland. Unfortunately, the rod is bent. I'm thinking the other rod may be bent also. Kind of hard to tell, but I'm thinking it very well may be. So I'll call the owner, tell them what we got, see how they want to go about fixing it. I'm going to call the machine shop first and see if they are able to press it out. It's about 1.5 inch rod. So let me see what our options are, then I'll call the owner.
Okay, yeah. Well, you're the, I understand, yeah. You the boss, I'll get her done, boss. Thank you. Owner said stab it back together. He's been using it for a bulldozer, and we'll worry about it when they start to leaking again.
All right, this is what they call the gland. This is what's got the rod seal and what they call a wiper in it. The wiper just wipes the rod off as it retracts back into the cylinder to keep dirt from getting in the cylinder. This wiper rubber's disintegrated and pretty much gone. So we're trying to get the wiper out of here so we can replace it. I usually just take a screwdriver here and stick it in here and twist the screwdriver and get the, and just keep prying it out. That's the wiper. It's just a press fit in this case. Now some wipers are rubber, plastic, whatever, and there's a groove cut in the front of the gland and it snaps in. And there are a couple different styles of those wipers, so get a good cross section of how everything looks. Let's say we got the cylinder and we have no idea, we have no parts for it. It's up to us to come across parts. Let's talk about the rod seal more than anything. We need to know the inside diameter, the outside diameter, and the height of the seal. To get your inside diameter, that's really easy. Measure your rod. I believe our rod's 1.5 inches. Pop the seal out. In a lot of instances, the seals don't come out without coming out in a million pieces, and this one's actually breaking as it's coming out. That pig gets behind there pretty good. There we go. Cleaning that groove out real good. Cleanliness is extremely important in working on hydraulics. So you'll plan on getting several cans of spray cleaner. Brake cleaner is what I use to clean things off. So we got a destroyed seal. We don't know what to buy to put in it. We measured our rod. We came up with 1.5 inches. Okay, so we don't have a seal to measure from. Next thing is get some Play-Doh. I just keep this on my shelf here in the shop. Press it into the groove and take it back out. Well, looky there. Now I can measure, make sure my calipers are zeroed. I can measure the thickness. It's 5/16. So 5/16 would be quarters 250. So this would be 0.325. So we know it's 1.5 inches, which is 1.5. Now we need to know the total diameter. And you take your same little piece of Play-Doh, and I've been kind of crude because I already got a seal. I'm not that worried about it. But we're going to measure what we got here. Somewhere in this neighborhood. Somewhere in the neighborhood of 0.250. So then you take that and you multiply it by 2, and then you add it to the rod diameter, and now you have the outside diameter of the seal, which in this case would be 2 inches. We got a new bearing surface for inside. That's what the rod rubs against as it moves in and out. They're split, so you get into the split. Using multiple tools here really works out pretty good. I never did clean my skinny screwdriver. That's a drag. We'll use a bigger one. There's the bearing surface. Snap the other one in. All right, she snapped in. Let's go ahead and stick the new seal in. New seal goes in this groove right back here, like so. Just start it in there, work it in by hand. I do have special tools that will twist the seal, make it fit, but usually I can get them by hand or with I'll use a blunt blade screwdriver sometime, just to kind of push it here and there, making sure not to tear the seal up. There she goes. Now your seals. That seal's called a U-cup. And there are different styles of U-cup. There are U-cups made strictly for being the rod seal. There are U-cups made for being the piston seal. So the rod seal's lip will be designed so that the inner lip is more aggressive than the outer lip, because the inner lip's what the rod seals at the rod. The piston U-cup, the outer lip will be more aggressive because it seals in the barrel at the external part of the outer diameter of the seal. So some U-cups are called loaded U-cups, and that's a U-cup with a O-ring inside of it, and that O-ring exerts pressure on the lips, forcing them out when there's no load. When it's static, that means the tractor's parked, it's just sitting there, there's no pressure on it. And that helps prevent static leaks. That's where a leak passes a seal when there's no load. Because when you put a load on it, the pressure gets underneath them lips and forces them out to seal even better. When I was in business, I always bought loaded U-cups, universal cups, so they would do rods and pistons. Now we're talking about the O-ring. The O-ring seals the outer edge of the gland into the bore. The gland doesn't move once it's in there and in place. So you just have to have an O-ring to keep hydraulics from sneaking by. And this O-ring here is not in good shape. It's not reusable. You wouldn't want to reuse an O-ring anyways. So let's pull this O-ring out. But I got to leave behind the O-ring right here is a backup ring. And that should always be on the O-ring should face the pressure first, and the backup ring something for the O-ring to push against when under pressure. So let's real quick talk about the piston. Sometimes pistons have U-cups. There'll be a U-cup facing in every direction the pressure comes from. So the pressure pushes it this way, there'll be a U-cup with its lip facing this way. Then when it's pressed back this way, this other U-cup would be facing the other way. But in this case, it uses a Teflon seal right here. Bearings look like they're permanently on there because I don't see a split. See this spot right here? Probably from that bent rod exerting pressure on the heel of this piston. and it's dragging in that cylinder, causing that wear spot. All right, last thing is the wiper. I'm gonna make a comment. This gland has been apart quite a few times. This is all broke up. There's still some lip, and I'm not that worried about it because that big snap ring I took off at first is just to prevent this from being sucked into the cylinder. That's not really where the concern is. The concern would be that internal snap ring that actually goes up and presses against here. That is important because the pressures created inside the cylinder when you're working it are trying to push it out. So I'm not going to tell him he needs a new gland. I'm going to tell him it's in really poor shape, but there's some things you can get away with, and that's what I'm trying to say. I don't foresee any problem with him using this gland. So this wiper will just drive in there. I'll have to get a hammer and do that, but it just taps in. If it starts to tap in, just try to be gentle, because a lot of times he'll want to bend up on you if you're not careful. And then that's where you might find something like a piece of pipe or a socket that barely goes around the outside lip, and hit it evenly and try to drive it evenly all at one time. Let's talk about piston for a minute. This kind of seal right here, it's a Teflon or nylon or something like that. And I don't like to change them if I don't have to. So I inspect it, make sure it's not in bad shape. They don't have much elasticity to them. So when I put the new one on, I got to stretch it high enough to get over this. Then it's got to drop down into the groove that'll be right here. And it'll just sit there and keep their stretched out shape for a good long time. And over time, they'll stretch back into the right position. And also you can take a hose clamp or something and gently tighten it down to try to force it back into the shape it's supposed to be. Because if it's protruding out any further than it's supposed to be, when you go to push this piston up into that barrel, it's liable to damage this seal. So, I mean, its seal stands taller than the bearing surface. I can feel that. And it's not damaged. So I'm going to leave it. You want to go into the barrel, we'll want to put something on the O-ring, lubricate it. But for the threads, you want to get all the oil off of there and off of the nut. If I remember right, nylon lock nuts are one use only. Therefore, I'm going to use red Loctite. If you forget which way something like this goes on, look for the pattern of the nut. It goes on like this. Surprisingly, there's no O-ring in here. Sometimes there's an internal O-ring to seal the inside of the piston to the shaft. When you use Loctite, you want to remove all the oil residue off of the threads. And as usual, we try to keep everything clean going back together. I'm going to take a emery cloth and clean just around the outside of that barrel where it's a little rusty. And I'll probably get a little bit of grease to put on it. Raise the barrel up. Get it to where they're in alignment. Let's see if we can't get this sucker together. Piston started up there. It's probably about right in here. I'm figuring driving this gland in with the piston towards this end, it shouldn't have that much of a strain as if I did at that end. where this bow would be longer. It's my crazy way of thinking. Went in quite easy compared to getting it out. That's because the piston, the rod was sucked up all the way in there, and this bend was making itself known. The groove this snap ring sits in is square cut on the outer side, and on the inner side of that groove it's chamfered so that the O-ring on the gland doesn't hang up on it. It kind of lets it ramp and continue on into here. Going out's a different story. They tend to hang up and cut. Make sure this rascal snaps in, because this is very important. I heard it snap. You want to make darn certain it's in that groove. If not, everything could go shooting out the first time you extend the rods. Actually, you can, when you suck it in too. Either way, it could shoot it out. I believe we're in there. Next step will be to bring the rod out and let the piston drive the gland all the way out. It's in there. I can also hook up the hydraulic line, start the tractor, pressurize it, and use the hydraulics to suck that rod in. I'm not going to. Well, there you have it. I got the hydraulic cylinder back together and back on. I'd recommend next time he has a problem to get a new rod or get it straightened and get a new gland or get one made. Now, check with your local hydraulic shop. They may be able to make a rod cheaper than you can buy one from the manufacturer. And they can definitely make this gland. I don't know if it'd be cheaper or not, but you can compare. So there's more than one option is what I'm saying. And what else? Just a note about hydraulic lines. Double check what I'm about to tell you. But just because the rubber is torn or missing on a hydraulic line doesn't mean you need to run out and replace it. Under that rubber is compromised, and yes, you do. This upper line up here is nothing but wire braid. All the rubber is gone. So it's always been working like that for a long time. So you might want to double check that. Maybe Google it, just to prevent a hydraulic shop or somebody to blow a load of smoke up your butt telling you it does need to be replaced. Thank you for watching my video. Please hit the like button. Please subscribe to my channel. And remember, if you love life and learning new things, go aimless.com.